Hello, and welcome to our program, Astronomy for Everyone. We're going to begin the new year by taking a look at the old, some of the highlights from astronomy from 2020. Now, the story of COVID-19 has really affected us all. It's affected us in the fact that we now do the show remotely from our homes. And I'd like to bring in both John and Stephen to talk a little bit about that. John?
This has been a big change for us. It's actually working from home and trying to get everybody together and then doing the editing. It takes so much longer, and it's, you don't have the studio where everything's all pre-set up. And so, yeah, it's been a real task for us to put these shows on, but we're glad that we can still bring these to you.
That's for sure. Stephen?
Yeah, the studio is actually closed. The Wyandotte Municipal Studios closed in April, and they have remained closed. They will be closed for the foreseeable future. So we'll be continuing to do this.
But like I say, at least we have the technology to be able to do that. Well, COVID not only affected our show, of course, but it also affected the world and the astronomy community. I'm going to bring in Timothy Day, MD, to talk a little bit about why it's not a good idea for us to get together.
Yeah, Don. So as everybody is all too aware at this point, the way the COVID virus spreads is through aerosol droplets. And one of the things that takes place at an astronomy at the beach or other outdoor astronomy event is that we gather together in small, tight groups and we look through different people's telescopes, putting your eye up to an eyepiece to see what's in there, holding it maybe just gently with your fingertips, and above all, bringing your mouth, even masked, to within just inches of all the other equipment that other people will wanting to use next or use last. And this is just, it's one of the top 5 ways to perhaps take a chance on contracting COVID. With those high stakes at hand, we have discontinued our astronomy parties. And that's a sadness to us because there's so much energy that takes place in learning and transfer of information, and people get to play with toys besides their own, which is always a good idea in our hobby. You can look with other people's very expensive toys and then put them on your wish list for 5 years from now, or decide no. But we still do an amazing amount of activity just in the virtual mode. We're very lucky that way. And it's exciting to have people come into our Zoom calls who could have never been at one of our actual de facto at a beach star parties. We get people chiming in from the West Coast of the United States or even overseas. So as with all situations, there's positives and negatives. For now, because of the highly transmissible nature of the virus through aerosols, even with masks on, we don't do live star parties this year. And we're hoping for a return to that with the presence of vaccines on a widely available schedule here in the United States, perhaps sometime in the late summer or fall of 2021.
Anyone else want to chime in on that?
I was just going to mention, Don, that one of the advantages, though, is that we have now more online telescopes. And with these online telescopes, they're using cameras, and these cameras take long exposures, and they're able to see things that you normally wouldn't see, even looking through a very large telescope with just your own eye. So it does give us an opportunity to show off some of the things that we can see in the night sky that are normally very difficult to see in person.
Well, that's true. Plus, it gives us as amateur astronomers more time to use our own equipment. Also, it's really had an increase in the sales of astronomy equipment via the internet, people getting into the hobby that now that they have all this free time. So going from the negative to the positive of getting more people into the science and hobby of amateur astronomy. All right, well, now let's get into our lightning round of 2020 astronomy highlights, and we'll begin with Comet NEOWISE. John?
Comet NEOWISE, that happened pretty much in the spring at the beginning of COVID. So it kind of got dubbed the COVID comet. And one of the special things about this Comet NEOWISE was that it started off in at dusk that we could see it, and we could actually see that with our naked eye. And it actually, as it got higher in the sky, it was in the north part of the sky. And so it became circumpolar. And so being circumpolar, you could see it all night long. And so some of these pictures that I'm showing are showing you from dusk until dawn out at Island Lake State Park that I actually observed this comet. And that was really neat.
Anyone else with comments on Comet NEOWISE?
You know, I did get a chance to observe it with binoculars. I also got a chance to look at it even through just a regular camera lens. It turns out this is an object that's the tail so long you don't need a big telescope to appreciate it, because you wouldn't see most of the comet if you tried to use a big telescope. So actually it was a great object for very low power instruments, ordinary cameras on a tripod or a pair of binoculars.
Great. Our next topic is the Convoy to Mars. And Kevin, start us out, please.
Okay, we're going to have 3 countries on this 2020 Convoy to Mars. Obviously the USA from NASA, and we have the Chinese and a new player in town, the United Arab Emirates. Now the Chinese are going to send an orbiter with a deployable camera and a lander, as well as a rover. And again, with the Chinese, we don't get a whole lot of information out of them, but they did pick the place where they do want to land, and they are going to land at, they decided where they're going to land. It's going to be an impact basin called Utopia Planitia. So we don't know, so it's a fairly flat basin, so they're not going into a crater as some of the other landers would. Now the United Arab Emirates, on the other hand, this is their very first space mission, and considering the history of astronomy in the Arab world, that's kind of interesting. But they felt like it was important that their young people would have a high-tech way to get involved in high-tech as well as the space sciences. And it just so happens in 2021, it's the 50th anniversary of the United Arab Emirates. So the HOPE mission is what they're going to do. And basically, they are going to attack Mars from the standpoint of atmospheric dynamics. And they're also going to look at the overall climate of the planet for a long period of time. And they should be in orbit around Mars around February the 9th, if everything goes correctly. And they did do a couple of scientific missions on their way to Mars. And surprisingly, it involves the planet Venus, where they hooked up with other missions, and they have decided to calibrate their instruments, and they use the planet Venus as the point of calibration.
Interesting. John, how about Mars 2020?
Yeah, that's I was able to go down to the Cape for the launch of Mars 2020. So this one's kind of special to my heart. And the picture I'm showing you now is actually a mock-up of the Perseverance rover. And this is a full-size model of it. And the next picture, you can see that's the Mars 2020 rocket with the fairing on top. And that rover is actually stuffed inside of that fairing. That's the top part that looks like a cone. And this was a beautiful launch. This was on a Atlas V rocket. And you can see just how beautiful this was. And there it's going off into the sky. And yeah, that's the one thing that I do want to bring up, is that the United States is the only country that's landed an operational rover on Mars. Other people have landed on Mars, but their rovers have gone dead within a few minutes. So it's going to be a real opportunity for China if they succeed, and they'll be the second country to have a rover moving around on Mars.
Great. Well, John, right from there, why don't we segue into the solar orbiter?
the solar orbiter, that was another one that I was down there for the launch on that one. And the solar orbiter, what's different about it is that it's actually going transverse into a sort of a polar type orbit of the sun. And it's going to work in tandem with our Parker Solar Probe. So the Parker Solar Probe is actually going in an equatorial orbit. And what the solar orbiter is doing, it's going outside of the ecliptic plane of the solar system and is actually going at about a 25-degree angle at its greatest point. But from that point, it's going to be able to capture the north and south pole of the sun, which is something that we have never seen before for many of our spacecraft. What it's doing, it's almost like an orbit that's similar to the orbit of a comet, where it's very elliptical. And so it gets close to the sun at one point, then it swings out past Venus and uses Venus as a slingshot to keep up its speed and stuff. And it goes past Venus out to about the orbit of Earth and then swings back to the sun. So at its furthest point, it's out towards Earth, and at its closest point, that's when it's close to the sun.
Stephen, what about the campfires?
Sure. So the solar orbiter has already imaged these small flares. They're very small flares, but there are quite a few of them. And they're thought to contribute to at least some of the energy that goes to heating the solar atmosphere, the corona, to 1,000,000+ degrees, which is considerably hotter than the surface of the sun, the photosphere. So you have these little flares. There's some magnetism going on. We know that, but we hope to learn more about these things in detail.
Coming up next, we're going to talk about the Great Conjunction. Tim Campbell.
Yeah. So so a conjunction? Anytime in astronomy, two objects appear to have the same, say, call it left to right or east to west coordinate, we call that a conjunction. Never mind the north-southness. And so with the planets Jupiter and Saturn going around the sun, you would think that, if you look at a textbook photo of the solar system, everything is in this perfectly flat disk. But that's not reality. The reality is every planet orbits in a plane that's slightly askew from the next planet. Saturn is roughly 10 times farther away from the sun in liberally rounded values than our Earth. Jupiter's about 5 times. So Jupiter goes around faster, about 12 years for Jupiter to do an orbit, about 30 years for Saturn to do an orbit. And that means when Jupiter's done just one orbit, Saturn's advanced a little bit. So you get one of these conjunctions where Jupiter finally catches up with Saturn again about every 20 years. But because those planes are askew, they don't really get that close to each other. They're several degrees apart. This time they were in just 6 minutes of arc with each other because they happened to be passing at a point where their planes were almost intersecting. So we got a spectacularly close and very beautiful conjunction that we don't get very often.
All right, John.
Yeah, I took some images of the Great Conjunction, and one of the best things about this conjunction is that looking at it with your naked eye, because with the naked eye, the planets look like one, but once you start putting magnification on it, you start splitting the planets and they start looking further away in distance, which takes away from what a conjunction is. So the first picture here I start off with, this is with a 200mm lens, and this was the day before the Great Conjunction because that was the only day we really had clear skies that I could observe it with. So here you can see Jupiter's on the bottom and Saturn's on the top. In the next picture, we take it and I kind of split changed my aperture settings so that we could get a distinguished picture of both Jupiter and Saturn, and we had the picture of the moons of Jupiter in this picture. And actually, there was a fifth one everybody thought was a moon, but on this image that I took from Stellarium, it actually showed that that was an imposter. It was actually a star that was lined up perfectly with the other moons, and it looked like it was actually a moon of Jupiter instead. And the third picture was at even a higher magnification. And this one I like because you could see both the bands on Jupiter and you could see the rings of Saturn in the same picture in the same image. So that was pretty neat to see all that.
It sure was. Last year was also the 30th anniversary of the Hubble Space Telescope. And Mr. Campbell, I understand you have a little bit of context for the picture that you're going to show us.
Yeah, so 30 years of Hubble, several service missions to repair things, optics, reaction wheels, and things like that to keep it steered. It's been doing a fantastic job for science. And some of the images that well, not some, but most of the images that it takes are quite breathtaking. This particular image that I want to talk about is probably my personal favorite, right? There's no best, everybody has their own favorites, but this one is my personal favorite. This is the Hubble Ultra Deep Field. So the director of the Space Telescope gets to have a certain amount of time where they get to just decide, this is what I would like to do with the Space Telescope. Normally you have to submit a proposal and it gets approved, but the director gets some personal time on it. And they chose to point the telescope at a piece of sky where there was absolutely nothing and hold the telescope there for 10 days just to see what happens when you point this instrument at nothing. Do you get anything? And this is the result. This image has roughly 10,000 galaxies in it. It's a very, very tall piece of sky. I'm sorry, very small piece of sky, only about 2.4 arc seconds, right? So an arc second is, 1/60th of an arc minute, which is 1/60th of 1 degree. So this is a really tiny piece of sky. If you take a penny, a Lincoln head cent, and hold that penny so that it's at arm's length away from you, and look not just what's behind the penny, not what's just behind Abraham Lincoln's head, but look behind just the eyeball. If you can squint so hard as to see the eyeball, that's what 2.4 arc seconds looks like that far away. Every single thing you see in this image is hiding behind that eyeball. And was it a fluke, right? Did they just get lucky? No, they've done this a few times with the Hubble Space Telescope. And every time they do it, the image is just absolutely packed with galaxies. A couple of the things in this images are stars. You'll note the stars, they have diffraction spikes on them. I think I counted 5 of them. I don't know if there are more, but almost every little pixel you see, no matter how insignificant, is a galaxy. Some of these billions of light years away.
And of course, that taken by the Hubble Space Telescope, but there's a number of objects out in the sky that really look better through a backyard telescope, such as the double cluster, which to me looks like diamonds on black velvet. Then, of course, you've got the quintessential galaxy, the Andromeda Galaxy, our nearest large galaxy neighbor. There's also M42, the great nebula in Orion, the Sword of Orion. And then you've got M45 in that same neighborhood, the Pleiades or the Seven Sisters, as they're known. Another big discovery in last year was discovery of phosphine gas on Venus. Tim C.
Yeah, so this was really exciting when it happened because of what phosphine represents. You can create phosphine in very, very high pressure situations, such as deep inside Jupiter, and then maybe have currents that convect that up toward the surface of the planet. But on planets like Earth and Venus, there are no known ways to create phosphine without biology, so while not a discovery of life, it appeared to be the discovery of a marker for life. And so this became very interesting, as you could imagine, the first time possibly finding this. It turns out, under closer scrutiny, the excitement was perhaps a bit overblown, and maybe Tim Day can kind of comment on that.
Hi, Tim. Yeah, the presence of phosphine on Venus really would have been a showstopper, a real wow moment. And the difficulty with seeing such a tiny little signal, and remember, we're talking about a little biological atom or molecule, excuse me, in the planetary atmosphere of another planet, so Venus's atmosphere. So that's already quite a good ways away. And we're talking about just looking at the light that's shifted a little bit. And we look at the chemical signature of these absorption bands or other bands going through their radio telescopes or submillimeter telescopes. This isn't even optical light we're talking about. So it's already an impossibly difficult job from the bottom of our own atmosphere all the way into Venus's atmosphere to see a molecule that usually only exists when bacteria belch life here on Earth. So phosphine is kind of like a waste gas made by bacteria. The thing is, it goes away real quickly. So it has to have some way of being constantly regenerated, or a few hundred years later, it's gone. And so we were all excited. Hey, a gas that has to be regenerated by a biological process must be getting created some interesting way. That's really cool. The good part about science is that we check and then we recheck and then we recheck. And in this one instance, it may be that we've run the mark a little bit. Well, time will tell. It could still be phosphine. You know, we're not, the jury is out.
Yeah, we shall see. Wrapping up real quickly, there were 3 robotic missions, sample return missions. One from China called Chang'e 5 that will be returning samples that are about 2 to 3 billion years younger than the samples we have from Apollo. These will be used to help improve calibration techniques for estimating the age of surfaces and other objects in our solar system. From Japan, Hayabusa 2, returning samples from the asteroid Ryugu, it's a near-Earth object. They brought back about 5.4 grams of material that will be shared with scientists around the world. And also the NASA OSIRIS-ReX mission that went to asteroid Bennu. It was quite a boulder-strewn asteroid, and so they had to take quite a bit of time to decide where they were going to map out their touch-and-go sampling maneuver. But they worked it out and got about 2 ounces of material that they hope will reveal conditions that existed in the early solar system. Those samples will be returned in September of 2023. I want to thank all of my guests for being part of this look back at 2020. If you have any questions, please send us an email. And coming up next is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for January 2021? We just had the solstice in December. So the nights were the longest in the north and shortest in the south for the whole year on the 21st. But this month, January, also has long nights in the north, basically for the full month. The month starts with the third quarter on January 6th, the new moon on the 13th, the first quarter on the 20th, and the full moon on the 28th. Shown here is Mercury, Neptune, Mars, and Uranus on the 20th of January, just a few minutes, in fact, after sunset. Mercury goes from Sagittarius to Capricornus over the month and sets in the evening. It's best at the end of the month. And that's partly because on the 23rd we have max eastern elongation, so it's farthest from the sun. Mars is in Pisces and goes to Aries over the month and sets a little after midnight. Uranus is in Aries and sets a little further after midnight. Uranus should be easier to spot near Mars. You'll need binoculars and a decent chart. Neptune is in Aquarius and sets just like an hour or so after sunset. It is best at the beginning of the month. You will need binoculars and a decent sky chart. Venus is best at the beginning of the month and is shown here on the first, about an hour or so before sunrise. Venus is in Ophiuchus and moves to Sagittarius. It is best at the beginning of the month. Now, the Sagittarius bit, hang on to that, because here we have a chart showing Jupiter, Saturn, and Pluto. Of these three, Pluto is in fact in Sagittarius, and you can see also the Sun is in this image, meaning that all three of these planets are very close to the Sun. And that's because they have superior conjunction, where they go behind the Sun relative to the Earth. Pluto happens on the 14th, Saturn happens on the 23rd, and Jupiter has superior conjunction on the 28th. So what do we look for if we don't have these gems to look at? Well, we have M35 shown here between Gemini and Orion. Now, it lies just to the right of the feet of Gemini, but Gemini is on his side probably, and certainly in this image, and so that's up just above the foot of the upper foot of the Gemini, the twins. Now, if you keep going to the right, which is up in this image, you may spot the similar M37 and M36 clusters. These are easy objects to spot, even in high light pollution cities. That's because stars are point-like, and optics make them brighter, but don't make the background brighter. Now, the three bright stars that form Orion's belt are vertical in this image. Orion's head is toward Gemini, and the feet are obviously to the right. The three slightly dimmer stars in a row form the sword. They are going off to the right in this image. The sword hangs from Orion's belt. The middle of these stars has been marked here in red. It is the Orion Nebula, M42. This is the brightest of the nebula because it is close and it is really quite large. It should not be missed, especially in binoculars or a telescope. In very small binoculars, 8x21, the fuzzy nebula of M42 is discernible when compared to the nearby point-like stars. In larger telescopes, more detail is available. And that is what's up in the night sky for January 2021. Remember, we don't charge for this show, but we may tax your brain.